Okay. Yeah. Hi everyone. My name is Nikolai Semiachkin, and I'm happy to present you today my talk about how we can use LLMs to estimate probabilities of unique events. So a bit about myself. I've been working as a data scientist for more than 7 years, either as data scientist or in related roles like data engineer or ML engineer. Was working on different projects in different domains with different types of data. But this is what I do by day. By night, I turn into a prediction market enthusiast. I've been interested in this topic for a while, was reading up on it, but also starting like the beginning of last year, I'm regularly practicing it, making predictions on prediction market platforms. So what I want to talk about today, I want to first start with the old school approach to the problem, how humans try to forecast unique events, and if there are any good, what were the ACE tournaments and the good judgment project, and who are the superforecasters and what makes them super. And after that, we will switch to a more hype topic, which is how we can use LLMs to do the same. We'll follow their evolution and discuss current state of the art and also current benchmarks and challenges. So, as data scientists, we are used to task of estimating probabilities, but it's usually probabilities of certain type of events, like will the user click on the ad, or will they buy an item? Is this text violating service rules? However, our real lives is full of events that are very impactful, but also one of a kind. So we can't use our standard methods to forecast them. I've included a few examples from real prediction markets. So these are real situations on which people are betting real money. And if you notice like a few weird ones, like is Earth flat, or the one about Jesus, this is also real, and like there are real people who bet money on that Earth is actually flat. However, it has more to do with prediction market mechanics than actual probabilities. I'll touch more on that later. So, what these questions have in common is that governments and large corporations are very interested in accurate forecasts. But also we, as individuals, can also benefit from it, for example, to make better financial decisions. However, as I mentioned, we can't use our standard ML methods to estimate these probabilities. And this is the difference between statistical and judgmental forecasting. So statistical forecasting is the one we are most familiar with. It's like basically machine learning. We get data, train a model, and then infer model on the previously unseen data. However, in judgmental forecasting, we don't have this luxury. We don't have like actual data points. Each data point, if we even can call it that, is unique, and we have to kind of look for historical analogies, look for like expert opinions, read the recent news, and somehow synthesize it into a probabilistic call. You might wonder if it's like even possible, or is it just fancy random guessing, which is like no better than random guessing, and you will be right to question it in that way. Because when we are unfamiliar with some topic, it's common to follow experts. However, it's a running joke that expert predictions are of a quality of a dart-throwing chimp. So here is an example. Jim Cramer is a US TV show host who, on his show, makes some forecasts about stock market, and he was so famous for his mispredictions that he had an ETF named after him, which like aimed to do opposite of he was suggesting on the show. And apparently, United States government also was concerned about its expert predictions quality because they tasked an agency called IARPA with solving it. And this agency is a agency modeled after DARPA, which you might have heard about. And its mission basically to fund high-impact projects that will help national intelligence services. And one of the projects it funded was ACE tournaments. It was a series of tournaments in 2010, 2015. It consisted of up to 150 questions per year, focusing on typical questions that are of interest to the governments, like election results, policy decisions, gold prices, and so on. And a bunch of volunteers were forecasting there, and their predictions were recorded and evaluated. So the idea was to do to forecasting what evidence-based approach did to medicine. In medicine, we have double-blind experiments, control groups, and so on. And they wanted to do the same to forecasting, just figure out what stuff works for probability estimation and what doesn't. So the metric they chose to evaluate was called Brier score, and it's kind of a square difference between predicted probability and the actual outcome, which is either 0 or 1. If you are familiar with machine learning, you will recognize mean squared error, and basically it is this what this metric is. And another useful metric is a calibration plot. Basically, if you're predicting that the probability of event will be 70%, you want out of all events for which you predicted this probability to happen 70% of the time. And the way to visualize it and kind of estimate is a calibration plot. Okay, and the tournament results were quite sensational because 5 teams participated. They were all university research labs. They had to beat a baseline which was wisdom of crowd prediction. So baseline was a bunch of people with no training in analytics. They made predictions, they were averaged, and that was the baseline. And it's actually a pretty strong baseline because usually that's how market works, like stock market. You get a bunch of people basically averaging stock price, and we consider that rational market. So again, questions were typical prediction market questions regarding some government policies. And what's interesting is one team that was clearly a standout. The team was called the Good Judgment Project because in the first year they beat this control group by 60%, comparing Brier scores. In the second year it was 78%. And what's most interesting part is that they even outperformed the professional analysts who had access to classified data. And they were so good that for the following years, EARPA stopped funding for all other teams. Okay, so what was this magical project? It was led by Philip Tetlock, and Philip Tetlock is the guy when it comes to forecasting because he was working in the field since the 80s. He first made a name for himself during a long-term study of quality of forecasting United States elections. It's commenting on the study, he actually coined the phrase of expert being as accurate as a dart-throwing chimp. And he's still active. Currently, he's still regularly publishing papers, also on the topic on using LLMs for forecasting. So what was the secret sauce? There were several key ideas. First, they started with recruiting a bunch of people. There were close to 3,000 volunteers. They give them training based on probability reasoning and cognitive biases. Also, they were assigned to work in a team, so they can discuss their analysis with each other and look on the problem from various sides. And it improved calibration. And they were tracking. So the GGP had to aggregate the individual predictions to make like final predictions for the tournament, and they were doing it using smart weighting and also extremizing, so like pushing more closer to either 0 or 1. So one of the most interesting part was the guidelines that they gave to forecasters. We don't have time to go through it in detail because the main topic is using LLMs. But to give you a few ideas, like one was to try break problems into sub-problems. Basically, like in this example, let's say we want to make an estimate. OpenAI announces it has achieved AGI this year. It can happen either because they actually achieved it and announces it, but more likely would be it's kind of a fake announcement, which is either like hacks the social media account and post it, or it's like some tweak of the rules where Sam Altman will post something that we will consider yes outcome by the rules. After that, the advice to start with base rate. It's rooted also in cognitive biases analysis, because the research shows that people get attached to the initial estimate and not change it much when new evidence arrived. So they suggest start base rate with some default probability for this type of events. For some event, it will be relatively easy. So, for example, with inflation be higher than 5% this year, we can use like share of years where it happened earlier. But for most questions, we can't just get the statistic easily. And in that case, we have to use some kind of back-of-the-envelope estimations. So for the previous question, the base rate could be probability of company social media account being hacked. And we can think about like this. So is it like 10%? No, probably way too high. 1%? Well, it's like one company out of 100. I don't think they're being hacked that often. So maybe 0.1%. Okay, like sounds plausible. We can go with that. And then they suggest like incorporating information from inside view, so information specific to this question. And in this example, we can think that existing on this question itself on prediction market, where people can like bet on it, create extra incentive to like hack account and post an announcement, and we can like multiply base rates by some value. Another suggestion also from like cognitive biases research was to tweak the question like in different ways to make yourself focus on different perspective. So during its research and during tournament, Good Judgment Project found out that some people were consistently better than others. It was about like top 2%, and they called them Superforecasters. Like to give some perspective, Superforecasters were usually having Brier score the same as regular forecasters, when regular forecasters were forecasting like 3 months away, and Superforecasters were forecasting like 6 months away. So like basically kind of in some way 2 times better forecasting ability. And what's interesting is their background. Most of them, like there were no like certain pattern. They had different backgrounds, but there were some traits that they shared. They usually had a wide range of interests, so we're reading books basically on random topics. They had the reasonable math knowledge because although for most of this type of questions you don't need like some fancy math, sometimes it's helpful to be able to like model something using math models. And they were also a bit of news junkies. They liked following the news, and it was helpful because they could update their predictions often when they had new evidence. Yes, but however, the claim from the project leaders was that the main difference is that it was in the way of thinking about the problem. So basically, they were just very good at this type of work that, like I showed on the previous slides. Basically, consistently working through each possibility, step by step, decomposing the problem. Okay, and the last step of the GGP submission to the tournament was aggregating. And so first they were aggregating based on forecaster's previous performance. They were including both previous historical Brier scores and update frequency, because like update frequency also played a big role in having like up-to-date estimate. And they were using extremizing algorithm. This is a bit less intuitive, but we can think about it this way. So a bunch of people thought about the problem. They thought about about it from different perspective. And if one person accumulated all this knowledge, they would also be like more certain. And that's why they pushed combined forecast either closer to 0 or to 1. Yeah, they also had like this fancy naming for like 10 advices how to do better forecasts. I won't go through them in detail. Yeah, but this project was 10 years ago. Do we know anything about how good humans are like right now in real time? And for that, we can take a look at prediction markets. There are a few of them. Some allow betting with real money, some with play money. Let's take a look on how it's doing. So this is a calibration plot, which I mentioned earlier. And if you look at it, it looks like very well calibrated. So the theoretical probability is like, if theoretical probability is like 70%, then aggregate probability for in prediction markets is like also very close to 70%. Another thing that you might notice is that, well, it's actually hard to notice on black and white, but real money markets are a bit closer to being ideally calibrated, and that's why I also like them better, because people like put their money where their mouth is. And another interesting pattern is that how Brier score in prediction markets decreases with volume, which is kind of expected, but still interesting to notice. So like the more people bet, the better aggregated probability estimate is. But if you want to turn into prediction market to get some like estimate on the topic that is bothering you, you should keep in mind that there are other factors influencing the price there. So, for example, looking at this chart, in April, there were people thinking that there is 3% probability of Earth being flat, and you can basically bet no and get about like 4% analyzed return on that. Okay, why this happening? The reason is time value of money. So for people who bet yes, it's actually clear because they will lock their money in the bet and they don't want to do it for free. But what's the motivation of people who bet yes? Because they'll just lock their money and then lose it in the end of the year. And it turns out that motivation of these people is actually they're betting that no bettors will need their money earlier, like for some more profitable investment, and they will sell at a loss. And if like no bettors, let's say, bought at 97 and sell at 96, it means that corresponding yes bettors bought at 3%, like meaning like 3 cents, and sell at 4 cents, which is like 30% return, and that's their bet. Okay, this was a bit off topic. I just included it because I think it's fun. Now let's get to the main part. So probably you get the idea how it can work for human forecasting, and maybe you also get the idea that it's kind of demanding slow work. So you have to like split the problem, think about each step separately, find relevant news, find like historical analogies and so on. And on one hand, it's like demanding work, and on the other hand, it's mostly text data in that or like other way. And we know which technology works best with the text data. So this field is new, and almost all papers about using LLMs for forecasting are like from this year or from the past year. So how difficult can it be? We have text data, we just feed it into LLM and ask, okay, what is the probability of this event? And we're done. So let's see how it was working out historically. The first paper to attempt it was in 2023. They did basically what I showed on the previous slide. They feed it this prompt, like in this chart, you're a Superforecaster, blah, blah, blah. You will predict probability for this kind of event. You will consider different perspectives. And they also included basically a question description, which is like title, resolution criteria, and so on. So how did it work out? It didn't work out so well because it was 2023. It was basically last century in LLM years. They were doing it on GPT-4, which at the time did not have internet access, and the authors also didn't try to like include in the prompt some recent information. The test was done on 23 questions from Metaculus. It was an ongoing tournament, and there was no significant difference from always predict 50% baseline. And at the time, human crowd did much better, like more than 2 times better, right? Okay, next attempt came in 2024. It was partially from the same authors. Now they were testing a bunch of models, some open source, some closed source. The test was done also on Metaculus prediction platform. This time, some models had internet access. They were also ensembling model predictions, like which is kind of right thing to do, because like if human crowd works better than individual predictions, then the same should be true for LLMs. And another impactful thing was that they included human crowd prediction in the prompt. So yes, when prompting model to make a prediction, they're also saying that current estimate from humans is like this. Okay, how did it work? And this time they claim that results are very similar to human crowd score. And if you look at the table, some models are actually doing even better, but I think because it's not outside confidence intervals, they settled with the claiming that it's similar to human crowd. So it's like impressive improvement. Okay, it was last year. Before we continue, let's talk a bit what makes benchmarking, forecasting benchmarking difficult, because usually how it works, we have some data set, we can train a model or like tweak existing model, run it again on the same data set, and compare how the score has changed. So basically we are limited only by our ideas and our hardware. But in forecasting, it's not like that, because we can't forecast on past events, because it will like 100% will be data leak. We can try forecasting past events, which happened after knowledge cutoff. That's better, but it brings other problems. For example, models have different cutoff dates, so it's like harder to evaluate. And also, if you want to test like incorporating recent data in the prompt, we'll be in trouble, because okay, we will filter news to only include news that happened before the event, but actually like dating news is not very reliable. There can be like not accurate dates on which this news was posted, and so on. And we're left with forecasting ongoing events. It's like the most reliable way. There is no chance of data leak, but it takes too long. And there were actually one paper claiming superhuman forecasting results, but they got its results based on like historical data, and that's why I don't think they will be reproducible in real time, because especially given that the overall approach was not much different from papers I showed earlier. Okay, so where to go to understand the current state of the art in forecasting? For like core LLMs, we have this chat arena where LLMs answer questions, answer prompts, and people compare it real time. Is there anything similar for forecasting? And there are actually a few of such baselines, a few such benchmarks that I find interesting, and one of them is Metaculus AI forecasting benchmark. So Metaculus is a prediction market, and it hosts tournaments for humans usually, but starting last year, they were also hosting this separate bot tournament. The rules were like no human in the loop. Questions are open at random time for a short time frame. It's usually like 30 minutes. And the bot must post comments explaining their reasoning alongside each forecast. Example questions, again, typical for the prediction markets. And this is an example of reasoning from the winning bot of the last season of this competition. It's actually not very informative, so I wanted to look at it to understand like which approach they were using, but it feels obfuscated because they mentioned like team 1 give this estimate, team 2 gives this estimate, but it's not clear from the reasoning where this team 1 and team 2 came from, and like what were the steps in the analysis. So this is not very informative. However, if you look at the leaderboard, there are 3 entries marked with the letter M, and this is basically baselines that Metaculus provided. And so while we can't have a look at like closed source boards, it's reasonable to assume that they're not much better than baselines. So we can have a look at baselines to understand how like current state-of-the-art bots work. And the way they work is like very similar to the pipeline I showed initially. So first they get the recent news. So there's like separate prompt for that, because they also use some kind of LLM API for that. So you are an assistant to Superforecaster, blah, blah, blah. Here's the question. Here's the question, how question outcome will be determined. And so they're tasked with getting the most recent information. In the baseline, they allow to use either Ask News or Perplexity, but Ask News performed better. And so after that, might be hard to see. So, but basically, a rather simple prompt. So again, you are a professional forecaster interviewing for a job. Here's your question. Here's the question background. Here's the research done on the previous step, like it's inserted in the prompt. And after that, there is some guidelines on how to do it, like predict status, like explain what will need to happen for status quo to be kept, what would trigger the yes outcome, what would trigger the no outcome, and so on. And so here's the example reasoning. The full reasoning from this baseline is actually like 20 plus A4 pages of text. So I'm only selecting a few interesting parts. It outputs some stats based on that. So here the model that was used was GPT 4.1. And it was run also like 5 times to average predictions later. And each this LLM forecaster was following through the analysis like shown in the previous prompt. And here's the like example analysis. So the question was about S&P 500 increase, and so it goes like this. First query, nothing changed. Plausible no scenario. I truncated it, but it goes like few events that can happen that will trigger drop in S&P 500. Plausible yes scenario. Blah blah blah, and it comes up with probability like 83%. So it goes like this 5 times for each forecaster, and then output basically averaged probability. Okay, but is it better than humans? This benchmark does not answer that. However, we know that there was one bot that scored higher in this bot tournament, and it later participated in a human tournament and placed there in 8th place, which is like pretty high. But to get a better idea how we can compare human accuracy and bot accuracy, we can turn to a different benchmark, and this is Forecast Bench. This is one of the papers that and one of the benchmarks that is done by Philip Tetlock, who I mentioned earlier. So it is a continuously updated benchmark. They are basically pulling questions from different prediction market platforms and also generating their own questions via specified templates from Yahoo Finance. So basically, they have a question like about predicting stock market prices. Okay, and they have 2 leaderboards. One is baseline leaderboard. Its goal to test raw LLM forecasting ability, like without any extra tools, any scaffolding, any agentic frameworks, just raw input to LLM and like raw output. And so if you look at this leaderboard, the first place is held by Superforecaster's median forecast. And the second place is surprisingly Gemini. It happened actually literally yesterday, because when I was initially preparing the slides, public median forecast was on the second place. But yesterday I was updating them, and Gemini turned out to be on the second place. It's not reliable, so like confidence interval, I think not suggesting that it's like reliably better than public forecast, but it's still like illustrating to the speed of progress. Okay, so according to this baseline, superforecasters are way better than LLMs, and public is close, but also better than most LLMs. However, if you look at the different leaderboard, this is a leaderboard where you can use like whatever tricks you can come up with for LLM and make just to make a forecast better. And do you see any difference? So the public median forecast is gone, and you have to scroll all the way to 22nd place to find them. And the difference, if you look just at the model titles, it's clear that the most kind of impactful thing that make models improve their predictions and push down public forecast was including crowd forecast in the prompt. So somehow LLMs can get the human forecast and adjust it based on their own analysis to be better than just human crowd prediction. Okay, and this is what Forecasting Institute says on this topic. Forecasting Institute is the entity that manages this benchmark, and so it says that a year ago, public median forecast was on the 2nd place, right behind Superforecasters, and now it's only on the 22nd place. This achievement represents a significant milestone in AI forecasting capability. And they also kind of extrapolate this trend of improving LLM forecasting capabilities and predict that they will achieve Superforecasters quality in the late 2026. Third benchmark, it's less interesting. It's mostly like very similar to Forecast Bench. However, I like the part where they estimate revenue forecasting of LLMs. So it goes like this. Human analysts try to estimate revenue from company reports, and LLMs try to do the same. And if LLM are closer to the truth, we give a point to LLM. Otherwise, we give point to humans. So currently, the best LLM is winning 45% of the time, which is like, so humans are still doing better, but for me, it's still very impressive win rate. Okay, to summarize, what are the important factors for LLM? If they have access to the most recent information, it helps. Also, averaging across multiple runs, it's kind of simulating what we do when we aggregate human predictions. And kind of killer feature is including human predictions in the prompt. And when we include human predictions, LLM are already doing better than general public. They're still doing worse than Superforecasters. However, there's a trend which suggests they will achieve this level of quality. Okay, and to summarize this whole topic, we don't know the future, but we can know the outcome distribution, or at least we can estimate it, and it is the next best thing. Forecasting is a skill, and there are guidelines and research on how to do it better, how to become better at it. And LLMs are better than general public in forecasting, but still worse than Superforecasters. If you want to learn more on this, I have two suggestions. So if you want to get better at human forecasting, I suggest this book by Philip Tetlock called Superforecasting. It's basically about the Good Judgment project and how they were training Superforecasters, some examples on how they were thinking about the problems. And I think if you like literature on cognitive biases, like Thinking Fast and Slow, you will like this book because they have a lot of intersecting topics. And if you want to get into LLM forecasting, I suggest you start with Metaculus benchmark research page. It has like nice instructions and also have a list of literature relevant to this. Yeah, and that's all from my side. You can download the presentation if you want, and I'm open for Q&A.
If you have a question, please raise your hand or use your microphone.
Thank you very much for the very interesting presentation. one of the key tricks LLMs can do to increase quality of forecasting was to get more recent information, like to develop large LLMs. Question, what is the role of deterministic reasoning in this? Like the ability of an LLM to write a program which will download statistics, will compute things, and will calculate information usable for a forecast. So how big is the role of this ability of modern LLMs?
Okay, I don't no, I don't know it firsthand, so I don't know about any research that tried that. I guess it could improve like the quality further if we include some kind of a pipeline that if you need some data, just like write some code to process it. For example, I don't know if it needs to look up some statistical tables. I guess currently it will just basically the usual way try to read it token by token and extract information. Maybe it can be improved by like automatically generating code to do it, but it sounds like a quite complex thing to do, and I'm not aware that somebody was trying that.
Yeah, thank you for the presentation. And I would like to ask, maybe somebody asked it before, or maybe you mentioned that, but I missed it. I'm sorry. So the prompt you showed, it was about when you ask LLM about the outcome, yes, by text, via text. And is there some data about how well they perform when you ask to write an alpha or some algorithm to trade, and then you run it, compared to human?
So the question is like not about prediction markets, but general ability for LM to write trading algorithm, right?
Well, how good are they at? This is kind of like an other approach to do the prediction, yes? Not just telling the outcome, but writing a script or alpha, yeah?
Yeah, actually, like I don't know about scripts, but it's like funny that you asked, because there is recently there was a competition launched, I think it's called NoF1.ai, where they're testing LMs at trading. Basically, they take like a bunch of frontier LMs and give them just textual data, some trading indicators data, or just some historical data on some, I think it was some crypto, and ask them to make decisions like whether they will buy, hold, or sell. And they were translating it real time. It's actually made, it was like a bit of a hyped thing, and it's currently ongoing. I think it started in the middle of October and will end on 3rd of November. The current results that two models are winning. Like each model were giving like 10K USD for trading, and DeepSeek and Qwen from Alibaba are like actually winning, and other models like Gemini and ChatGPT are losing money for some reason. The model, like the information is rather simple. I actually not sure it's not just kind of random fluctuations, because I don't think based on the information they were given in the prompt they can like beat the market, but it's still like interesting experiment.
Thanks a lot for your presentation. Very interesting topic. Pardon my ignorance on the topic. I think my question maybe is a continuation, because I didn't quite catch what kind of context is included in the prompts. I guess it's kind of news articles, financial statements, etc. What I wanted to ask is, do you know of any research that, let's say, also incorporates trying to understand how confident is LLM in the response by different metrics regarding the token probabilities, and try to like include it in the weighting or something, or does it really not make sense?
So your question is not about trading; it's about the general. Okay. Regarding estimating like how confident LLM is, I don't know, because I feel like we can estimate their confidence from like their kind of probability that they outputted, and we can kind of it should measure its internal state of how confident they are. Regarding the ways to measure it kind of in some external way, I don't know. I'm not aware of that.
Yeah, it's me again. I would like to ask, when we talk about like trading and money, this topic, we know that nobody actually shares if you got somebody, yes? Everybody's hiding if you got some profitable strategy or approach or, I don't know, tips and tricks, you don't show them in public, yes? So do you think, do you think somebody got something cool but not showing? Or maybe what's the percentage of, I mean, frontier like trading bots we see? What's the percentage of actual performance are they showing to public, you know?
Okay, so this is about again trading on like a real market like stock or crypto, not like prediction market, right? Just
well, any market, it doesn't matter really. It's still about money, yeah.
yes. So regarding prediction markets, I'm pretty sure that on real money prediction market, a lot of trading is done by bots, because if you look at the profile of some like users, there's some crazy amount of deals and crazy amount of like market on which predictions are made. So it's not like really feasible for a human to do. And also about prediction markets, like here, if you want to show off your model, you don't necessarily need to give away like your code, because, for example, in this forecast bench that I mentioned, you can make your submission, but your submission just consists of your like model prediction, so you don't need to give away code or something. So in that sense, it should be kind of reasonable display of the current state of the art. And regarding stock trading bots, I don't know. Like there is like more incentive to not give away any information. However, I doubt that like state of the art trading bots are based on LLMs directly, like LLMs making decisions, because I don't know. It's usually like very high speed and yeah.
Thank you.
Thanks once again. Maybe a bit abstract question. Are prediction-based markets optimal in the sense like stock market is optimal? Like all information is included in the price and like so on.
Yeah, that's a good question. The kind of key factor here is trading volume, because in stock market, when you like bet in stock market, you're competing with huge funds, with like Warren Buffett or Ray Dalio managing like billions, and they kind of fight each other, trying to make a better estimate where the price will go, and the volume is so high that it kind of converges, I think, on more or less like reasonable price. We can argue about that, but basically what makes stock market very efficient is that it's volume. And the prediction markets are not that popular. So there are a lot of markets that have less than 50,000 USD volume. And in that case, it's not like you are betting against efficient market. You are mostly betting against people like yourself who also not necessarily did some kind of deep analysis to arrive, and so that's why it's kind of less efficient due to volume, and also why it kind of more reasonable to expect that you can potentially profit from it than from predicting the stock market. I also want to share this slide. So this basically how Breyer score, which is like mean squared error between the prediction is outcome, differs between as volume increases. So if you have like 1 million volume, it's 4 times more accurate than if it's like less than 1,000. The absolute values are not very representative because I think it's calculated like either 4 or 12 times or 12 hours before the resolution, and like 12 hours before the 12 hours before the resolution, it's usually clear how a question will resolve, but the trend is still I think noticeable. So they are not very efficient except few markets where there are a lot of money. Like for last year United States elections, there were like 2 billions betted on the outcome, and so in that way you can think it's about very efficient.
Yeah, thank you for the interesting topic again. So my question is rather that if big companies have tons of resources, do they have clear advantage for these forecast topics? For what are the trends of them? So are they showing what they can? Yeah. So as I said, prediction markets are not like very developed. So in a way that like stock markets are, and there is little volume, so there is little incentive to have some hedge fund, prediction market hedge fund, which will bet like millions on some outcome. Yeah, I guess if you had even if you had 1 million, it would be hard to like spend it on prediction market in the way to earn money, because for most questions there is not just enough volume. So it's still a niche topic, which kind of upsets me, because I think it should be more popular. Answering your question, for large corporations who have a lot of resources, they're not basically interested in prediction markets because they can't earn like reasonable money for their efforts there. They can be interested in their own way. They can basically try to apply these forecasting practices for the problem like they face, like frame their company problems in terms of binary forecasting problem, and kind of use that. I don't know if that makes sense. It's very interesting for me. It's if they can, so some people can do build some bots on Twitter, on etc., on Facebook, I don't know, and they can have impact. Like for example, Sam Altman, only with his words he can have the impact, like in the presentation. So is it like are people trying to scrape some data and then aggregate some information, for example, then ask users' opinion, then so kind of bots that can catch people's information, then use it to forecast? Is it kind of, do you see some mechanism like that, or to use the public meaning to aggregate and influence again the public, kind of from vast data, I mean?
I'm not sure I get the question. So are you asking? Are you asking whether we can scrap Facebook for some people opinions to use in like some forecasting questions? I don't know. Like it's dependent on the question. For some, it would like make no sense, right? Because they're not dependent on public opinions. For some, I guess you can try doing that. I don't know. Like for election prediction, maybe you can try scraping Facebook to get some sentiment, but I don't know.
Because Facebook has advantage, clear advantage to build opinion based on some. So because it Facebook has access to all the questions.
Yeah, but okay. So you mean like Facebook? Like somebody at Facebook can process information to make a better bid on prediction markets? That's what you're saying.
So it influence on the next prediction. So how are they doing that?
You mean? I'm not sure I get it. Do they influence people predictions, or do they use?
To have some advantage of the vast data, to make some kind of to influence people's opinions, like, because maybe there are lots of threads, lots of discussions on some topics, they can gather that information, make agentic distillation and so filtering, and then use it for their own interest. Because kind of, I think that they have a clear advantage on people's opinions. Like it was kind of a clear position of them. Versus other people or other companies.
I think we have time for the last maybe question, and after that we have pizza there, so we can continue the discussion. So please, the last question.
Thank you for a great speech. I have such a question. There are many commercial companies that publish some data, financial data about finances. And many companies or individuals use this data, financial data, to train their models, their bots. So I mean that more or less this training data is correlated. They are using the same data. And many people that are using AI for trading will have the same issue when some unexpected big event will occur, because they trained their bot more or less on the same data. So what are the risks that all these people and companies will meet this big downtime when some unexpected big event happens? Thank you.
Are you asking me to give a probability estimate of how likely that some like black swan event happens that will break a lot of companies? Basically, economic crisis. I don't know. I can't do it on the spot. Or maybe I didn't get the question right. There is some probability of that happening.
Okay, thank you.